And it means what? It means nucleophile. Then what is nucleophile? Any idea?
The NS1, NS2 reaction.
Yeah, the one which is more electron rich. The species which come with a pair of electron, that is called nucleophile. Okay. And Anushka, we have seen in the last class that the carbon halogen bond is there. Carbon halogen bond is polar. Okay, because of the difference in electronegativity, difference in the tendency to pull electron. And suppose if you take a species which is having unpaired electrons, lone pair, we call it as a nucleophile. Okay, it can be minus. This is a general way to represent nucleophile. Okay, it will come in and push away because the nucleophile is coming with the electron pair. Okay, it will come in and join the carbon and it will push away the Br, right? Okay, this is nucleophilic substitution reaction. So Zan, is it clear?
Yes.
So there can be two ways. That's what we discussed, Anushka. What were the two mechanisms for nucleophilic substitution reaction in terms of sequence of arrival of nucleophile and departure of leaving group?
So it was SN1 and SN2.
Yeah, SN2 and SN1, right? And what's the basic difference? The difference is with respect to sequence of the arrival of nucleophile and departure of leaving group, right? So in SN2 reaction, there is a simultaneous bond formation and bond breaking. That's what we discussed. Bond formation with whom? Bond formation with the nucleophile. Simultaneous bond formation and bond breaking. Okay, and with whom the bond is breaking, Imad? Whose bond? Yeah, whose bond is breaking away? The leaving group.
Nucleophile.
Okay. Yeah, in SN2 reaction, the nucleophile is coming in and forming a bond, and the group which is already there, the halogen group is coming out. It is breaking away from the reactant molecule substrate, right? So both things happen simultaneously. And in SN1 reaction, how it happens? Then SN1 reaction, any idea?
Like it breaks and forms at the same time, right?
Yeah, in SN2, both formation and breaking occur at the same time. In SN1, Anushka, the leaving group break away first from the substrate. Okay, so for example, if we are having CH3 whole thrice tertiary group, it will break. Okay, Br minus will come out, leaving behind a carbocation. So this is the slow step, and That's why it is called unimolecular, because in unimolecular only one molecule is involved. SN1, substitution nucleophilic unimolecular. And because it is very branched, the nucleophile can't come directly. Okay, that's what the difference is. Then the nucleophile get attached, come and attack on this. So that's the main difference. Okay, so let's have some examples. And SN2 reactions, as we discussed, there are some questions related to the mechanism, that's how the bond breaking, how the bond forming is happening. But there are many questions with respect to the conversion, because they are widely used to convert alkyl halide to some other group. Okay, so let's do some conversion, and I will give you the substrate, I will give you the nucleophile. You need to put the nucleophile to the substrate, and you need to remove the leaving group. Okay, suppose if I ask you to convert, or I will directly give this reaction. Ethyl bromide, when you react with KCN, Imad, Anushka, Zen, what we are going to get?
CS3, CS2, KN, and then KBr.
CS3, CS2, and
CN.
yeah, CN. Imad and Anushka, what's your answer?
CS3, CS2, and then that's critical field.
CN will get attached. Okay.
Okay.
Examples of nucleophilic substitution reactions. So CN minus KCN, you can think as how you will know that the KCN is a nucleophile, because KCN dissociates as K plus and CN minus. Okay, and the CN minus, this is the polar bond. CN minus will get attracted, and the Br will come out, right? So Cn minus is a nucleophile and Br is a leaving group. Br minus comes out with the electron pair because its bond is weaker. And what's the IUPAC name of this? Yeah. Any idea, Anushka? What is the IUPAC name? How many carbon are there? 3 carbon atom. So propane, there is no double bond. So propane I'm using. And Cn is known as this triple bond N is known as nitrile. So this is propane nitrile, right? Okay, yeah. So what will happen? So this is a very, very important conversion. You take alkyl halide rayon and you react it with KCN, potassium cyanide, and the cyanide is the nucleophile that comes in and pushes away the Br minus. Okay, and you get the product which you get has 1 carbon more than the reactant. You can see over here, 2 carbon were there, and the product there were 3 carbon. There are 3 carbon. So propane nitride. How will you make butane nitride? Which alkyl halide you need to take? Can you tell me? So who is going to tell me which alkyl halide I need to take here to get butane Okay, I can give you the hint, little bit hint. Yeah, Ryan,
Yes, sir.
yeah, just tell me what alkyl halide we can take. Is it the chlorobutane, Anushka? Or is it chloropropane,
Sir, chlorobutane.
chlorobutane, or propane?
Sir, butane because we need to
Look,
make butane.
look, yeah. There is, how many carbon atom are there in butane nitride? 4 carbon,
4.
right, Zan? So 4 carbon are there, and 1 carbon we are bringing from with the help of CN, right, Imad? So
Yes, sir.
how many carbon atom uh, group we need to take here? I need to take the group having 3 carbon atom. Okay, then the CN will get attached. Totally, we will have 4 carbon. Zan, is it clear?
Yes.
CH3, CH2, Cl you need to take. The Cn minus is going to come in and it is going to push out the Cl minus. So Cl, so you will have CH3, CH2, CH2 and Cn, and this is known as step up reaction. Okay, means the number of carbon atoms are increasing. Okay. Ryan, what do you expect if you take CH3, CH2, Br and AgCN? Any idea? Imad, Anushka, Zen, tell me.
Is it
Ryan,
fingerprint reaction?
it is not Finkelstein. Finkelstein is NAI.
Oh, but it will be CH3, CH2, CN, and then AgBr, right?
CH3, yeah, what you thought is correct, but actually there is little slight change. Okay, though we expected the same thing, but there is a slight change. So because of that slight change, we need to change the way in which the CN is getting connected. Okay, let me show you why this change has happened. The silver plus is there and Cn minus is there. Yeah, so that's you thought correct. That the thing which you thought is correct, right? But silver has a tendency, Imad, to pull the electron pair. Due to which, because it pulls the electron pair, there is some overlapping which happens, and due to which the carbon and the silver acquires covalent character. Okay, that's why I've shown these dotted lines. Right, Riyan? Anushka, can you see this?
Yes, sir.
So carbon is getting involved in the partial covalent bond formation, and that is because of Zen and Imad, that is because of the silver, which has a tendency to pull the electrons. Okay. Now, if the carbon is getting involved in the bond formation, so now who is going to attack? There is one more characteristic of CN, Ryan, and then that is the CN is actually ambidentate nucleophile. It means it can attack from two sides. You can see the lone pair on both the sides. One is on carbon, another is on nitrogen. Okay. So normally in KCl, what happens? The K plus is comes out. It gets dissolved in the water because potassium doesn't have tendency to pull electron much because it is a lighter atom. So there you don't have the covalent bond for formation, and so Cn minus actually comes out, and because the negative charge is on Cn, so we connected the Cn minus through carbon atom. But in this case, the Cn minus is actually occupied. It is participating in the bond formation with Ag plus, and because of this, the carbon is now not free. It can't attack. But that doesn't mean the Cn minus can't attack. The Cn minus can still attack, but from the other side. It can attack from nitrogen side because that is still free. Okay, but and nitrogen also has a lone pair. Then only it can attack. So such type of nucleophile which can join themselves or which can attack from two sides, okay, are known as ambident or ambidentate nucleophiles. Is it clear? Zain, Imad, Ryan, Anushka, tell me any
Sir,
doubt? Yeah.
Yes,
sir,
sir.
I
Can you
didn't
just
understand what you mean by ambident.
Yeah, pardon?
Sir, I didn't understand what you mean by ambident nucleophile.
Ambidentate ligand is actually the ligand which has a lone pair on two different atoms. Okay. Suppose if this is the carbon atom, okay. So ambidentate ligand has a choice. Either it can attack from this in this way, or it can turn and it can also connect from the other side, right? Like this way or this. Why the nitrogen can attack? Why the cyanide is an ambidentate ligand, ambidentate nucleophile? Tell me. Because it has lone pair on two different sides, so it can connect itself either, or it can attack on this either from the carbon side, or then it can attack from the nitrogen side also. Is it clear? So if the nitrogen is attacking, then you need to make this structure. NC bond will form. Or if Cn minus carbon is attacking, then you need to write the upper structure. Is it clear? Anushka,
Yes, sir, understood.
Imad, what's your doubt?
no, actually same, sir. I also didn't understand ambident.
Yeah, I will give one more example. But in this case, when you take silver cyanide, why the carbon is not attacking Zain and Ryan? Tell me. You need to give the
Because of
reason.
ambident nucleophile, right?
Yeah, it
Because
is
of lone.
ambidentate. Yeah. But why it was not attacking? The carbon was not getting joined.
Because the one was getting dissolved in water.
Carbon actually was held by silver plus. The lone pair of the carbon was held by silver. That's why I've shown this line. They are not free. The carbon is having some association with the silver. So that's why I've written that it acquires a covalent bond character. Not complete bond, but some, because silver has a tendency to pull the electrons of the carbon. So there is some association. So because of this association, Ryan, the carbon is not available to attack. It's not available for attack. Is it clear? And if the carbon is not available for the attack, now who is going to attack? Yeah, Ryan? The attack will be from nitrogen side, because nitrogen side is still free. That lone pair can go and attack on the CH2Br. Is it clear? Zain, Anushka, Iman, any doubts?
Yes, sir,
No, sir,
understood.
Not sure.
Okay. So yeah, so when you take AgCN, you will have isocyanate form. This functional group is known as isocyanate. Or when you take KCN, the CN get attached. The carbon atom attacks. But if you take AgCN, the carbon is associated with silver, the nitrogen atom goes and attack. Is it clear? So this is isocyanate formation. Okay. So let me ask one more question. This is benzene ring. All of you know. Yeah, what's going to be the answer of this question?
So the CH2 and CN we can join, and then KBr, and then I can be just alone. Or
Yeah. So do I displace the iodine also?
no, I think we can just leave it there, right? Because you're
Yeah.
already discussing KC and
But if I take two moles, then yeah, this is correct. But why you chose only Br to be removed? Why not iodine?
iodine is stronger, right? It likes to attract itself, right? I2 like usually.
Yeah, actually, uh, yeah, Anushka, what's the reason? Imad,
Sir, I'm
iodine actually is having lone pair and being directly connected to the benzene ring. Rayan, this iodine, the lone pair and the benzene double bond, actually they get mixed up and they are involved in this is mixing up of electron, that is delocalization or resonance, and due to which it acquires partial double bond character. Is it clear? Zen, is it clear?
Yes, yes, sir.
Imad,
it's not clear.
Rayan, can you hear my voice?
Yes, sir.
So aryl halides are less reactive towards substitution reaction. The carbon halogen acquires partial double bond character due to resonance, and if something is connected by double bond, it's very difficult for us to remove it. Okay, even if you take 2 mole or if you even if you take more KCN, then also the I will not be removed under normal condition. Okay, so here you can show this partial double bond character, and that will let you know that it is less reactive. Okay, so let's take one more example of same kind of ambident nucleophile. This is bromomethane. Okay, if I react it with If I react this bromomethane with potassium nitrite and silver nitrite, what I am going to get? Same thing, but you need to know the structure of NO2. It's NO2 minus. I will show you one structure of NO2 minus. It is like this. So there is O minus, and there is K plus. Potassium is always plus alkali metal. So normally, what do you expect? Yeah, Iman?
Will it get reacted with KNO2 or
When it is reacted with KNO2.
yeah?
Potassium actually comes out very easily because potassium has 18 electrons which are there in the argon. Okay, so it gets argon is a noble gas and potassium plus is very stable. It comes out, it gets separated very easily because it is very stable on its own. Right? So it is an NO2 minus nitrite. So Ryan and Zen, from where the NO2 minus, which is the attacking atom of NO2 minus? Can you tell me?
The Br is attacking, right?
Br you need to remove. NO2 minus is going to attack. This is the nucleophile. But which atom, from which atom it is going to attack on the CH3Br? Yeah, Anushka? Ryan? Zen, Imad, tell me.
Sir, will NO2 attack CH3?
Yeah, it will react and it will normally the attacking atom is the atom which is having high electron charge density O minus. Okay, right?
So, but how do you find that this has the highest O minus or the high density?
Because it has minus charge. Normally in the CN also we attacked C minus because K plus separated. So minus the atom which is having the carrying the minus charge is more unstable because it is charged atom. It is having more density, so it is more reactive. So normally the attack will be from the oxygen side, right? Zen, is
Yes,
it
sir.
clear or not? And the Br is going to come out because Br is halogen, it can come out. CH3ONO, okay, right? And Ryan, it is known as Imad, it is known as methyl nitrite. ONO is known as nitrate.
Sir, but here in the question, so how does CH3 then react with AgNO2?
How do CH3 will react with?
AgNO2, will it react or how?
It will react. It will react.
Yes.
And along with it, you form KBr was obtained. Methyl nitrite, ONO is nitrite. But Ag plus has some tendency, okay, which is not there in K plus. Anushka, what is going to happen with AgNO2? Let me show you the structure of AgNO2. So this is still NO2 minus. But look here, The O minus which is having directly connected to Ag plus, that is actually having the partial covalent bond. So it is not free to attack. So now the question comes to our mind, Rian and Zen. Now who will go, because oxygen is not free to attack, who will attack? So what's the answer? If O can't go and attack, initially with potassium, potassium was freed and O minus attacked. It was like this. Yeah, Zen?
Yes. So can AG attack or no?
Ag plus will get precipitated with AgBr finally. So Ag will not attack. Out of these, there is one another atom, that is nitrogen. Okay. Why can't O minus go and attack? Because O minus is actually involved in covalent bond formation. Is it clear or not? Anushka?
Yes, sir. Clear.
So
Yeah,
this
did
is also
NO2?
yeah.
Sir, just one doubt. Sir, how did NO2 react to the attack? Did it attack AgNO2 or did it again attack CH3?
No, actually, these are two different reactions. Okay.
Okay.
Don't think that actually what instead of writing two separate, just I write one time. Okay, and I asked you what you will get if you react this with KNO2 or what you will get, or right?
Yes, yes.
Is it clear? Two different reactions, but instead of I have shown simultaneously by two arrows. These are two different reactions. Okay. So in the first reaction, yeah. In the first reaction, this will form. And if you react again, take CH3Br, and if you take reactor with AgNO2, this will form. Okay. And this is known as nitromethane. Okay. Is it clear?
Yes, sir. Thank you.
Ryan, Anushka, Zen.
Yes, sir. Understood.
So this is also an example. So let me, this is also an example of ambident ligand or nucleophile, ambident nucleophile, right? Okay. So let's have some more question. So CH3, CH2, Br is there. You react it with NAI, acetone. Okay. You got A. A was reacted with AgNO2. Okay. You got B plus. Actually, you don't worry about the inorganic product. Mainly, you write the carbon containing product. Okay. So what are going to be the structure of A and B?
CH3, CH2I.
Yeah, CH3, CH2I is correct. And which reaction is this? This is Finkelstein reaction. Anushka, is it clear?
Yes, sir.
Imad,
Yes, okay.
Rayan, clear? And when you react it again, this is the structure of A. And in A, when you react it with AgNO2, remember, you have to remember this picture in your mind. O minus is actually involved with the bond with Ag. So O minus now will not attack. Nitrogen lone pair is going to attack and will displace the I. So the structure of B is going to be CH3, CH2, NO. Okay. Is it clear?
Yes, sir.
Right? So this is nitrogen. So there are other nucleophiles also, and there is a list of nucleophiles given in your NCERT book. Let me open it. Yeah. This one. Wait, it's coming. Yeah. Okay. So this is the list of all the nucleophiles. Very basic table, but very, very important. If you react RX is the alkyl halide with KOH, OH minus is going to attack. But in normal nucleophile, the tension is not that how it is going to get connected. Because normal nucleophile will attach in only one manner. So if you have OH minus, you get ROH. Okay, if you react with water, there also the nucleophile is water, so OH will form. Okay. If you react it with R dash O minus is going to come and attack. So these are the list of nucleophile. With I minus, Ri is going to form, and this is going to be the Finkelstein reaction. And with NH3, amine is going to form, primary amine. Okay. Look here, with CN, RCN will form, with AgCN, NC will form isocyanate. With KNO2, O minus is going to attack. So RONO is going to form alkyl nitrite, and with AgNO2, you are going to form nitroalkane. Okay. This is the reaction with amines. The amines are actually lone. The nitrogen atom is having the lone pair. So they go and attack and displace the halogen. If you have RCO minus, the CO minus is going to attack. H minus actually this is H minus. H minus will attack and you will have RH. Similarly, if you have R minus is going to attack. And you will have on RH, R minus is, if it comes and attack, you have R dash form. Okay. So this is the table which gives us the list of nucleophiles. Zan and Rayan, is it clear? Can you see that? Yeah, Rayan, Anushka, Himad.
Yes, sir.
Yeah, so this is also used for the conversion. Look here, ambident nucleophile, very simple it is. Okay, so I hope all of you understood what it means, right? Okay. Good. So there are various set of nucleophiles which you can use. This will be used in a lot of upcoming chapters. And suppose if you want to make amine, okay. So how will you convert ethane? There are conversions given in the book. Convert ethane to ethanamine. That would be CH3, CH2, NH2. How will you do that? Yeah. So how you can bring NH2 group? You can just now we have seen in the table you can bring the NH2 group by heating with ammonia. Ammonia is a nucleophile, NH3 is a nucleophile. Right, Zen?
Sir, I understand what.
How you are going to convert? Any idea?
No,
What
sir.
set of reagents? Yeah, what set of reagents you need? So first of all, this is which group? This is which compound? Alkane. Okay. Right. So alkane, you need to convert it to alkyl halide, bromide or chloride. Why I need to convert alkane to alkyl, bromide or chloride? Why can't I directly convert it to amine? What's the reason, Imad? Anushka? Why I need to convert it to alkyl halide? Why can't I bring NH2 group? Because, okay, directly I can't bring the NH2 group. I need to first connect Cl or Br. Right, Imad?
Yes, sir. But for CH3, will it like ammonia? Can we just treat it with ammonia and then can
Directly
use
you
it?
can't treat. You need some electronegative group which can come out, and ammonia can come in as a
Okay.
nucleophile, right?
Okay.
So you
Okay.
need to attach, first you need to attach some electronegative group which can come out as minus. Zen,
Okay.
are you getting?
Yes, sir. But
Yeah, you need to bring some electronegative group which can come out as minus by pulling away the electron pair. And the alkanes do not have any electronegative group. So we can convert it very easily. So what was the method which used to convert alkane to alkyl halide? That could be your alkyl chloride or bromide. Yeah.
Sir, was it halogenation?
Yeah, you need to take chlorine and yeah, good. And light, sunlight, UV light, right? Or sunlight also written. So because that sunlight or UV light will give energy to break the Cl-Cl bond, and that Cl bond will, as you get Cl radicals, they will abstract H, and that the once the H is removed, you will have Cl. Ryan, are you getting?
Yes, sir.
So what's the name of this reaction? It is famously known as what? Then could you
the
recall the name?
free radical halogenation.
Yeah, free radical halogenation or photohalogenation. Very good. Photohalogenation in the presence of light, or photohalogenation of alkanes. Free radical. Because by heating you get, or by light you get free radicals. Right. Now you have Cl. Okay. And the Cl can be, and now the ethyl chloride is more reactive because the Cl has a tendency to pull electron. So there is some partial charges also, Anushka. So now the carbon can be attacked very easily. Okay. So which will be the next reagent in order to achieve this conversion? Which will be my next reagent, Anushka? Which will displace the Cl minus by NH2. Yeah, Anushka, tell me which reagent you can use which can displace, yeah, Cl minus and bring in NH2.
Sir, can we use,
Pardon?
sir, can we use KCl?
We just need NH2, okay. Either we can use NH2 minus NaNH2, okay, or we can use ammonia, neutral ammonia. Ammonia is a nucleophile. Is it clear?
So can we just use NH2 or?
Actually, NH2 minus is very difficult to handle. You can use NaNH2 also. But ammonia is normally available, so that is more easy to handle. You can use ammonia and you can have this ammonia will attack. Okay, let me tell you, this is substitution reaction. Okay, ammonia is a nucleophile because it carries a pair of electrons. So immediately you will get this product NH3 because it was neutral. After giving lone pair, it will have plus charge and Cl minus, and you can you can remove HCl by heating and you will get NH2. Okay, is it clear?
Yes, sir. Yes.
Okay, so actually, suppose if someone asks you then to convert ethane to ethanol, how you are going to do it?
So like, can you use like NH2OH, right? Somewhere like in the reaction.
Yeah, remember one thing, whenever you start with alkane, this is for all the chapters, for alcohol chapter, for aldehyde chapter, for ketone, carboxylic acid, amines. Whenever you start with alkane, and I always tell to all my students, even those who are preparing for JEE and NEET and advanced and all, whenever you start with alkane, first convert it to alkyl halide by photohalogenation. Why? Because the halide, once you have the halide, it will come out very easily, and you can put the group which you want to. Okay, right? So now tell me what I need to do. Which reagent should I use here? Yeah.
NH2 or no?
No, first I need to bring in Cl or Br.
Oh,
So what should I take in this case? Rayan, can you tell me? Himad, yeah.
so how Cl2?
Actually, when you mix it with chlorine and when you heat it with sunlight, actually the sunlight breaks the chlorine into Cl radical. That's why the thing which Zen was telling, and this Cl radical, actually, this is not the nucleophilic substitution. This breaks this H and the Cl radical join itself to the CH2. This is photohalogenation reaction in the presence of sunlight or UV light.
Okay.
Is that clear?
Yes, sir.
So whenever you have alkane, start with photohalogenation. Write it as a thumb rule. Okay, it's very, very important. Whenever you have an alkane, use photohalogenation, and then you can do whatever you want. Okay, so you ended up with this, but actually you plan to prepare this OH. So how can you bring in the OH?
NaOH.
Yeah, now you can react with NaOH, and then this is step 1, and in step 2 you can now very easily displace the Cl by NaOH aqueous or KOH aqueous, right? Okay. Right.
Yes, sir.
So these are nucleophilic substitution reactions on alkyl halide, but you need to have an alkyl halide. And if you are given with alkane, you can convert it to alkyl halide very easily by reacting it with halogen and sunlight. That is called photohalogenation. Means halogenation of alkane in the presence of light. And once you have halogen, that halogen group can be displaced very easily, or it can be substituted very easily. So you have that substitution reaction happening. Okay, clear? So I hope this is clear to all of you, right? So in case of any doubt, you can try it on your own. You can try the conversions which are given in the back exercise, this one, in the NCRT book, right? So you can do those conversions and all, but they are easy. You need to think in the same way. A lot of conversions are given in the back exercise. All these conversions, okay, you can do. Okay, look here. This one we did just now. Okay. The next thing is this is substitution reaction on sp3 carbon or alkyl halide, which occurred very easily. Okay, but will the same substitution reaction occur on aromatic halides?
No, sir.
No. Why?
Sir, because they have got maybe because of the strong bonds.
Yeah, strong bonds, correct. Actually, suppose this CH3Br is there or CH3Cl is there. This bond is only one bond, okay, single bond. It's very reactive, and the nucleophile can come in and it will push out the Cl minus. But what about the aromatic halide? If you have that same Cl atom connected to benzene ring, what's going to happen? The Cl has a pair of electrons which are not participating in the bonding known as lone pair. These lone pair will get participated in the resonance. They get mixed up with the electrons of the benzene, and due to this, the carbon chlorine bond acquires partial double bond character. And actually there is also this bond is less polar, okay, because there is an electron density getting back into the benzene ring, so this is less polar. So this is alkyl halide or normal aliphatic halide, which is the sp3 carbon. It's very reactive toward nucleophilic substitution. But this is aryl halide or aromatic halide. Very less reactive. Because the carbon chlorine bond or has been directly connected to benzene, it has acquired double bond character. So now let me compare the situation by showing you the reaction. CH3Cl is there, KOH aqueous is there, and just now Zan told that it will happen and OHCl minus will come out and OH will get attached, CH3OH and KCl. That's correct. It happened very easily. Okay. But when you take this chlorobenzene, it's not an easy task. No reaction occurs, right? Because of the same reason. So what you need to do to make it happen? Yeah, Rehan? Zen, any idea?
We should heat it.
Yeah, we should heat it. So this reaction happens under a very vigorous condition. Under high temperature and pressure. So actually you need to take one more step because it is you need to write H plus also. So this occurs in a very, very difficult situation. Look at these conditions. Okay. And this is known as Dawes process. And that is used for the preparation of phenol from chlorobenzene. Okay. It is not an easy task, very difficult because the OH minus has to come in. It need to have a lot of energy to come in and join itself to the benzene because benzene is a double bond, right? So how it happens? Is it the SN1 mechanism or SN2 mechanism?
SN2.
It is SN2, SN1. The answer is none of these because this is not a alkyl group. Okay, this fall in SN1 actually the nucleophile comes in and the leaving group goes simultaneously. SN2, SN1 actually the leaving group come out first. Okay, and leaving behind a cation and then the nucleophile comes in. SN2 can't happen here because it is doubly bonded, partial double bond character. So you can't expect the nucleophile to come in and the leaving group to go away directly. It's very difficult. It cannot happen. And you can't happen, and SN1 also can't happen because you can't expect the Cl to break on its own because being connected to double bond, it's very difficult for the Cl to break. Okay. So now how it happens? It happens by an entirely new mechanism, and that is called nucleophilic aromatic substitution. Biomolecular nucleophilic aromatic substitution reaction, how it happens, let me show you. You have a chlorobenzene and you took NaOH, the OH minus comes in, and that is only possible by this temperature, which is very high. Normally it can't happen. Okay, this you have seen, nothing was happening, right, Zen? Zen, you can see here, nothing was happening. Only under high temperature, so OH minus will come. And the nucleophile has a tendency, or wherever you see the nucleophile, and when it comes, you need to push away some of the electron in order to make space for the incoming nucleophile, because that nucleophile is coming with its own electron pair. So what, Anushka, I will do, I will push this pi bond and keep these two electrons aside. Okay, like this. Is it clear? This is the intermediate. Rian, Imad.
But sir, how can we find that this substance is intermediate and
Now there are actually certain techniques, experimental techniques, which let us to know the charge and the structure. Okay, but you don't have to worry about there. There is a technique called NMR, nuclear magnetic resonance. Spectroscopy techniques are there. That those techniques actually let you know what is the intermediate. Okay, so actually this OH minus comes in, and the question is, this carbon is already making 4 bonds, so how that OH minus can come and fits in here? Okay, so if that OH minus is coming in and bringing in the electron pair, something need to be pushed aside, and who is going to get pushed aside? The pi electron, right? It will be pushed aside and minus charge will be there. This minus charge can push aside the double bond in the ring, and it can move within the ring like this. Okay, so this is the movement of the minus charge, which is resonance. Okay, but this is not the final answer, because this minus can't stay in this manner for long. Is it clear? It need to be turned into a neutral compound. Okay, like we started with chlorobenzene. So this minus will again try to become neutral. So it will try to again get back to the benzene ring. Okay, let me make the benzene. So in order to make the benzene, this minus or the pair of electron need to get back to that ring form, and between the two carbon atom of the ring, and that need to form a bond with the ring. But again, the same problem is there. So this carbon, it has made 4 bonds. So if that minus charge is trying to come in and form a double bond, how is it possible? There should be some group which need to be pulled out, thrown away. And who will be pulled out? The one who is more electronegative, or the group which can come out very easily. That is Cl minus. Okay, so the next step is this minus charge forms this, and Cl minus comes. Okay, is it clear? So this is a difficult step, but you don't have to write all the things again and again. Okay, if someone asks you how it is happening, then only you need to say it. Otherwise, you just need to express it as a high temperature. Okay, is it clear? Zain, Imad, Rayan, Anushka.
Yes, sir, understood.
Yeah, so you can, it's there in the book also, so you can see it. They have given the example of this. Okay, yeah, this one. Okay, look at the temperature. They have given in Kelvin. I have shown you in Celsius, and they have explained how this is happening. The OH minus comes in and it push away the electron. There is a minus form. That minus circulate within the ring. Okay, that minus try to form the benzene again, and in that it pushes away the Cl minus out, and that's how you get the product. Okay, this first step is difficult step. Definitely it is going to be the slow step, and that's why it is known as bimolecular nucleophilic aromatic substitution. Nucleophilic means the nucleophile is coming and attacking on the ring. Aromatic means this ring is benzene ring is aromatic in nature, and this substitution is happening on the aromatic ring. So nucleophilic aromatic substitution reaction means substitution on aromatic halides. This require very strong condition. This is a slow step. It is a difficult step because actually this OH minus need to have a lot of energy to come in and get connected to the carbon of the benzene. And suppose if you have just one more thing, one more pattern which you can notice here. Suppose if you have NO2 group connected at ortho and para positions. These are ortho and para position. These are ortho position. This is para position. Then the reaction is becoming easier and easier. Can you see? Can you notice it? Okay. You can notice it by noticing the change in temperature. Okay. So here the temperature which you took was 623 and here it is 443. Okay. Somewhere around 250 or something, right? And here the temperature has reduced further the moment you put the two NO2 groups. And suppose if you put three NO2 groups at at ortho and para positions, these NO2 groups are electron withdrawing group. Look what has happened. The substitution has occurred even by simple water. You don't have taken even the NaOH and but you simply warm it. You don't even heat it very strongly and you get the picric acid. This, what is the common name of this? Remember it? Picric acid, right? It is 2,4,6-trinitrophenol. Okay. So why the NO2 group must be helping in some way or the other. That's why when you have more and more NO2 group at the ortho and para position, the reaction is becoming easier, and which is indicated by the temperature of the reaction and which is coming down and down. Okay. So why NO2 is helping out? Because there is an attack of a nucleophile. Nucleophile is bringing in its own electron pair. Okay, the NO2 group which is there, that is helping the nucleophile. Look, it is helping the intermediate to get stabilized. Look here, this minus charge will be pulled by NO2, so it will become more stable. So electron withdrawing groups, if they are present, they will help the nucleophilic substitution on aromatic rings to occur with more easily. Okay, so but the electron withdrawing group need to be placed at a specific position at ortho and para, because the minus charge is circulating from ortho and para positions only. So if you have NO2 group, this minus will get stabilized because NO2 is having plus charge, and plus and minus attract each other, so it will get stabilized. But where you need to put the NO2 group? At ortho position, at para position, but keeping the NO2 group at the meta position. This is meta. Okay, with respect to the Cl, this is ortho, para, this is meta. Meta position will not help. Can you tell me then why it will not help much? Why it is not
The
going to
meta
help?
position.
Yeah, if I put a nitro group on the meta position, it will not make the reaction very easy.
Either stability or partial proton character.
Yeah, the minus charge actually which is forming is passing through ortho and para positions. Look here. So it is passing through ortho position, para position, ortho position. So it is not coming on meta. So if you place the NO2 group at the meta position, it is not going to stabilize the negative charge. Okay. So that's why it is not very reactive. Okay. Just, but this thing, all these things you don't have to draw. Okay. You don't have to draw these things. Just you need to keep this in mind that it is going to happen more easily. Okay. Clear? We will see it again in the preparation of phenol chapter. Okay, next chapter is going to be alcohol ethers. So there also a lot of concepts will get repeated and they will be same. Anushka, Ryan, any doubts in this? Let me know. Anushka and Ryan, Imar. Anushka, yeah, tell me.
It's a bit confusing, but once I revise it again, it will be clear.
Just write, let me know if you have any confusion. Yeah, first time it appears, but you don't have to write all these things. Just write the answer.
Yes.
But you need to have it in your mind that it is going to be a difficult step. Okay, it is difficult. Suppose if I ask you where the OH minus is going to come and join easily, Imar, which compound is more reactive towards reaction with OH minus? A or B? Which is more reactive?
reactive.
More reactive. A is more reactive or B?
Yes,
Sir, B.
Reactivity towards NaOH. So OH minus will come in and will bring minus charge at these positions. You need to have that picture in the mind. Okay. Little bit idea you need. Don't have to draw the actual thing. In this, if the OH minus comes in and get attached to the carbon where the Cl is there, so there also. So now tell me where the minus charge is going to get more stabilized. Where it will become more stabilized. NO2 has plus charge in it.
A, right, is the answer.
Yeah, A is the right answer because this minus is going to be taken away by the NO2 also. So NO2 in a way is helping the minus to get dispersed, and it will, because NO2 has plus and the minus and plus will become more stable. But you need to have the NO2, Anushka, right at the position where the minus charge is passing. So this NO2 can't help this minus charge to get stabilized because the minus charge will come at ortho position. It will directly come at the para. Why it will come at ortho and para? Because once you move this, these two electrons try to form a bond here, and because they are trying to form the bond here, I need to push away the bond which is already there to the next carbon. That's how it happens. Is it clear?
Yes, sir.
Okay, so you get this. So you need to have an electron withdrawing group. You can write electron withdrawing group increase the rate of nucleophilic substitution reaction on aromatic rings. Electron withdrawing group at ortho and para positions. Okay, that you can write. Okay. Now let me discuss some of the other reactions. These are the nucleophilic substitution reaction of alkyl halides and aromatic halides. Let me discuss some other reactions of alkyl halides. And this reaction you might have studied in your class 11. It's given in your 12th NCRT also. I can show you. So Wood's reaction. So what this reaction is, can any one of you explain me? Riyan, Imad, Zain, Anushka? What this reaction is? You need to take an alkyl halide. need to react it with sodium in the presence of ether which is free from any water, means dry ether. You will get an alkane. Which is having just the double the number of carbon atom which are there in the alkyl halide. Plus sodium salt. Okay. So whenever you want to double the size of the alkane, whenever you want to double the size of the alkane, or you need to first convert it to alkyl halide, and you need to alkyl halide when you react it with sodium in the presence of dry ether, which is also known as Wurtz reaction. The size of the alkyl halide get doubled, and you get an alkane which is having twice the number of carbon atom which were there in the original alkyl halide. Okay, let me show you one example, and let me tell you the way. This is the word in words I have written, what you use, what is the purpose. Let me tell you the way how to remember the reaction. Very easy way to remember the reaction. Suppose if I take CH3Cl, this is an alkyl halide. Wurtz reaction is given by alkyl halide. You need to balance it. You need to take 2 Na, okay, 2 moles of Na. Even if you don't balance it, okay, it's okay. But I am writing the complete balanced equation because you have taken 2 Na. There, 2 Na will combine with 2 Cl to give you 2 NaCl. And you need to write the alkyl halide once again, the second mole of alkyl halide, the second molecule of the alkyl halide. Okay. This is just a way, this is not a standard format. This is just a way why I have written this so that to make you remember. Okay. So it's so what you do, you put a box around these Cl halides and Na because they come out as twice NaCl. And what will happen to these two bonds through which the Cl were connected to? Are they going to stay in the air like this without being connected to anyone? Will they stay like this? No, they will come and join together. So what's the alkane which you will get? Is it clear? Zain, Imad, Ryan, Anushka.
Yes.
Can you just explain
Yes,
that
sir,
again?
understood.
Yeah. Yeah, Imad.
So can you just explain that again?
Yeah. What you do? You take alkyl halide.
Yeah.
You write the same alkyl halide, but in this way, face to face, in which the 2 Cl atoms are facing one another. You write the sodium molecules, 2 sodium atoms in the middle. You remove the 2 halogen and 2 sodium, make them as this salt and the alkane. Okay, is it clear?
Yes, sir.
So suppose if I use, so this is Wurtz reaction. Let's do Wurtz reaction is used to prepare the even numbered carbon atom alkane, the alkane having twice the number of carbon atom with respect to alkyl halide. So in alkyl halide, how many carbon atom were there? 2 carbon atoms. Okay. And when you heated them with the sodium, the halide got removed. And both the alkyl group joined together. So the final alkane was having 4 carbon atoms. Okay. So whenever you want to just double the size of the alkyl halide, think of Wurtz reaction. Is it clear? Ryan, what's going to be the answer to this? I will give you a hint. Bromination is very selective. Zen, just try it.
Same like
Yeah,
free radical hallucination, right?
yeah, this is free radical halogenation. Yeah, but where do I need to put the Br? That's my question is.
Can you use Marconi first or no?
That is for the addition of HBr on alkenes. Yeah, that is for addition of HBr. So actually, bromination is very selective. So the selectivity of bromination is more towards the tertiary hydrogen than for the secondary hydrogen and then for the primary hydrogen. Is it clear? So here you have only one. This is primary carbon because it is connected to one carbon. This is secondary carbon because it is connected to two carbon. So the bromine will get connected. If you have more options, then I'm telling, then you need to think in this way. Bromine will get connected to the secondary carbon, or if tertiary carbon is there, then it will get connected to the tertiary carbon. Is it clear to all of you? You need to remember this. Imad, Rayan,
Yes, sir.
Anushka,
Yes, sir.
Zain,
Yes.
because there were multiple hydrogens, so which one to remove, which one to uh, keep it as it is. You need to know the reactivity. Okay. So for bromine, you can write the bromination is very selective, and this is the selectivity. You need to react at tertiary carbon first, followed by secondary, then primary. Okay. You need to choose. So this is the product. Normally, what you suppose if someone asks you what is the product, you are mostly bothered about the organic product or the main product of containing the carbon atom in organic chemistry. You are not bothered much about HBr or something, some inorganic product, small molecule. Okay, then if I ask you if I reacted with sodium and ether, this is ether. Ether, you know what the functional group is? Oxygen connected to two alkyl group. This is diethyl ether. Okay, there are two ethyl. This is the for mixing sodium. That's it. This one. So what am I going to get? What is the IUPAC name of the alkene which I'm going to get? Tell me. Anushka, Zen, Ryan.
Is it like hexene?
Like,
Hexane because double, right? So yeah,
yeah,
pentane,
hexane.
hexane.
Yeah, it will be hexane, but from which carbon will they connect to one another? That you need to tell. Yeah, you are correct. Up to some extent. Yeah. From the which carbon will they connect? Where,
The BR.
where yeah, where the Br is. The Br is on the middle carbon. Okay. So these two molecules are going to connect. Hexane you will get, that's the common name. Okay, and so you need to write like this. Write the Br of one molecule facing the sodium and the Br of another molecule facing it makes life easy. We remember, just remove them, collect them, and remove them. Okay. Yeah. I hope you can see. So what will happen to these two bonds with which the Br atoms were connected? They will get removed, and they will join together. Okay. Rayan, are you there? Zen, is it clear? Imad, Anushka.
Yes, sir, clear.
So why
Yes,
we
sir.
have not made normal hexane Zen? Okay, this kind of hexane. So IUPAC name is, what's the IUPAC name? You need to select the longest chain.
2,3
Yeah, 2,3.
methyl butane.
Yeah, 2,3 dimethyl butane. Okay. Yeah. So if you have benzene in place of alkyl group, that is called Fittig reaction and Woods Fittig. So just go through it. Just let me show you in the book where it is. Fittig and Woods Fittig. Look here. Suppose if you have only alkyl groups reacting together with sodium, that is called Woods. If you have only benzene ring aromatic halides reacting with sodium, in the same way, look here, I have joined the two benzene ring, that is diphenyl, that is called Fittig reaction. And if you have one alkyl halide and one aromatic halide, okay, do the reaction in the same way. The approach is same. Just you need to remember the name. That is very, 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 very important. Okay. Woods says for aliphatic halides or alkyl halides, when two molecules of alkyl halide join together by the removal of halogen with the help of sodium, and if you join two benzene rings, okay, and if you join the two benzene rings together, and that is called Fittig reaction by removal of halogen atom with the help of sodium, okay, you get biphenyl. And if you remove if you join one benzene group and one alkyl group, and that is a mix of Woods and Fittig, so that is called Woods Fittig reaction. So I hope this is clear. Okay, so tomorrow we will be means in next class we will be covering more reactions, and hopefully I think it will get completed. We will try to complete next or maybe one more class next to next class, in which we will cover some general molecules which are of use, which are in use, like DDT, chloroform, some characteristics also. Okay, that we will discuss. Okay. After that, we will study alkyl and aryl. So go through the NCERT book and let me know. Just try it. But this Grignard is also there. I have not yet covered it. I will cover it. Don't worry about it. Compare some rates. Let me know what's the doubt is. Just read it. Just try some of the questions from the back exercise, the conversion questions. Okay. I have not completed all. We will complete in the upcoming classes. So don't worry about it. Okay, but you can do many of the questions which we discussed today. Okay, right? So let me end today's class. Okay, guys.
Thank you.
Bye,
Thank you.
everyone. Take
Bye,
care.
sir.
Okay, good night.
Sir, how will you get the recorded classes?
Pardon?
How will you get the classes, like the records?
Yeah, you can contact with the management. Okay, they will provide you the recorded